this section of this series of videos, we're going to be looking at measuring irregular plate part areas. There's a little bit involved in this, so we've had to break it up into a few sections. When I'm looking at this, a lot of the stuff we'll go through should really be revision from last year. I'm going to go over it again anyhow, but there are a couple of new things which will crop up for you. So the first thing I wanted to have a look at is the concept of paces and using paces to calculate areas. So when you're out, when surveyors are out in the field and things like that, they don't necessarily always have a lot of equipment with them. It's very hard to use a tape measure to measure, very long distances. So one of the things they use to get a rough idea of a measurement is pace lengths. So what they can do is they can just pace out a property and get an idea of how big it is. It's not 100% accurate, but generally it's good enough for their needs. So when we look at this here, we've got Felicity takes 32 paces to cover a distance of 28 metres. She finds that a rectangular sports field measures 250 paces by 190 paces. Calculate the dimension of the sports field and thus the area of the field. Really, whenever I get a question like this, I always draw a diagram just to get it clear in my head what's happening. So when I look at it, it's 255, and I'm just going to use P for paces by 190. So I'm just clear about what's happening here. It's a rectangular field. So I can't give an answer in paces, okay? So I need to convert this. What we need to look at is her pace length. Now when we are talking about pace length, it's the number of metres that she walks divided by the number of paces. So in this case, she's 28 metres divided by 32, and we have a pace length of 0.875 metres per pace. So now we've got this information, we can convert and make a diagram we can use. So when we look at this, we can say that the length of the field is 255 paces, and we can multiply it by 0.875, and we get 223.1 metres. Just going to move over here a little bit. The width is going to be 190 times 0.875, and we're going to end up with 166.3. So when I look at my diagram, rather than having paces, we can now put in metres. So it's 223.1 metres and 166.3 metres. So now we can use our area formula. So area is going to be length times width, which is 223.1 multiplied 166.3, and we get roughly 37,100 metres squared. So that's where we can use paces to work out area. We just need to work out a pace length here. What I want to look at here is something which people get notoriously wrong all the time, and this is bearing and back bearing. Okay? Now, when we look at it, put this one out of the book. When we have a bearing, the first question here isn't to do with the diagram. Okay? So the first question is a separate question. So it says the bearing of GH is 143. What is the back bearing? Now there is a rule which says if the bearing is less than 180, add 180. If the bearing is more than 180, subtract 180. If you can remember that, good. Just remember, this is what I like to tell my students and so that they remember it. The bearing has to be between 0 and 360. We've never ever seen a bearing which is different to that. So I just tell them, look, add 180 first, If it doesn't work, if it's not between 0 and 360, that means you're meant to take away. That way you don't really have to remember much. So, the back bearing for GH is simply 143 plus 180, which equals 323 degrees. So is that between 0 and 360? Yes, good, that's the correct back bearing. When I'm looking at the second one, we've got a diagram here. And it says, what is the back bearing of AB in the diagram? So when they talk like that, the forward bearing is A to B, so the backward bearing is going from B to A. Now something you can actually draw in these diagrams to get a better idea of what the answers should look like. I'm going from B to A. I'm working out what that angle is. So if you look at it, it's less than 90 degrees. So you can get a great idea straight up really quickly whether your answer is going to be right. So I'll just show you just for technique purposes. So I'm going to say back bearing for AB. Now, when I tell you just add 180, you don't have to write that down. So if I added 180 to this, I'm going to get to like 424. That's not between 0 and 360, so I know it can't be an add one. So what I do is, I then subtract. So it's 244, take 180, and I get 64 degrees. So you see, like when I drew the little diagram, we knew it's between 0 and 190. So 64 degrees, yep, we're probably in the right area. Gives us an indicator that we are correct. That's what the beauty of diagrams is. I can't recommend you drawing them high enough. Now, this one here is something called fall. Now, calculating fall is really, really easy. Fall simply means how far down did it go. So when I look at this, here's this red line running across the middle of the screen here. Now, what this is saying is that 0.243 means from the red line to the dirt. And that 2.437 means from the red line to the dirt. So if I want to know how far this fall has been, I do this number, take this number. And that's all I need to do for fall. So I can write fall equals 2.437, take 0.243. And when I put that in my calculator, I get my answer of 2.194 meters. The next bit's a little bit trickier. It says, hence, calculate the angle at which the ground slopes to the horizontal. What do you think I'm going to say? Draw a diagram. So when I draw my diagram, it looks like this, and it says the angle at which the ground slopes to the horizontal. So this is the ground, the horizontal is at the bottom, so it must mean it wants to look at that angle. In these questions, the horizontal is always the bottom of the triangle. We've got a 90-degree triangle, we can start looking at using trig. But we need some more information first. We need to know what we know. This is 16.42 meters. We can get that from the diagram. And why we bothered to calculate fall is because that's what the height of our triangle will be. So, go back to your trig days. If you remember your good old trig, you should realise that you need to label things. So that's my angle. This is my adjacent because it's next to both angles. This is my hypotenuse because it is opposite the 90-degree angle. And this is my opposite, A, because it's the only one left, and also because it is opposite the angle we're interested in. And we nearly always call that angle theta, which is that funny little circle-looking symbol. So, when I look at this, I go, okay, the information I have is for adjacent, and it is for opposite. So if I look at through my trig rules, the only trig rule with adjacent and opposite is tan. So tan, you remember the rule, I remember the naughty one, so I better not say it, but you can remember Sokotawa. Okay, so when I look at this, I can go, alright, fill it in. Tan, I don't know what the angle is, The opposite side is 2.194. The adjacent side is 16.42. Remember because tan's on that side, this is a type 3, which means you need to hit Shift 10 on your calculator and put the numbers in brackets. This doesn't confuse your calculator at all. And we end up with 7.61 degrees. If you're having trouble with your calculator, you need to come and see me or your teacher and see why you're not getting the right answer for that one. So that's just the starting point, and I'll just end it there for now for finding some irregular areas.